And in this live class, we want to continue from where we stopped in our previous class on circle geometry, which is one of the important and interesting topics under the topics we have in mathematics. Now, yesterday we have already looked at the definition, of circle. Definition of circle. We describe circle as locus of points which are equidistant from a fixed point. So you can as well watch the video on that. And also we look at some parts of circle, which are very important for us to know before we start proving theorems and solving problems under circle. And this part of circle like radius, like diameter, like chord, arc, sector, segment. So these are what we looked at in our previous class. So you can check that in order to have better understanding of all this. And we look at some lemma. Lemma simply means some facts before the actual theorem. So we discovered that a sector subtend angle at the center of a circle. Let's say this is the center of a circle. And we have a chord rather. A chord subtend two angles at the center. Let's call this chord AB. So this chord now form this angle when it's connected from A to the center and to B. So we have this angle AOB at the center. And there's two angles there. We have one inside and the angle outside. The one inside is obtuse angle. So we have obtuse angle AOB. And also we have the one outside, that's reflex. That's reflex angle AOB. So this, we have this very important. And the same way, we discover as well that a chord can also subtend two angles at circumference of a circle. We have a circle with center O, and we are given a chord. Let's call it AB as well. And this chord AB subtend. We discover that the word subtend in mathematics, when you hear the word subtend is synonymous to the word formed. So when an angle is subtend by something, it means it's formed by that chord. So that means we can form the angle at the circumference here. Also, we form from these 2 points now. This point at the circumference is an angle ACB. So we have angle ACB at the upper part, which is the major segments. Because a chord separates a circle into 2 segments, the minor and the major. Minor is the smaller one, while major is the bigger one. Of course, now it can also form an angle at the circumference here in the minor segment, which implies here we label this as D, and we also have angle ADB. These two angles are formed at the circumference of the circle. So this is a lemma for us here. For us to now go to the theorem proper. Now let's look at the first theorem. And this first theorem is where all other theorems are attached, like is the basis for the theorems. So basic understanding of this particular theorem one will help us in understanding all other theorems and also make it easier for us to solve problems related to circle geometry. Now, We call this theorem theorem 1 here. Theorem 1. Now let's look at what this theorem is saying. Theorem 1 states that the angle subtends, let's do that, by a chord or an arc, might be an arc, at the center of a circle is twice that which its subtends at the circumference of the circle. Now, this theorem is an interesting one. Let's look at the word this in the theorem. You say the angle subtend. The word subtend is not new to us again. It's same thing as the whole form. By a chord. A chord is not new to us again, or an arc. At the center, also center of a circle is not new to us. Now, it's twice. Look at it. This is a keyword. The angle at center is twice that which is obtained at the circumference. So in other words, angle at the center is double. The word twice means double or times 2. So angle at the center is times 2 that of angle at the circumference. Okay? Now, for us to prove this theorem, we state what is given. So for any theorem to be proved, first state all the parameter, like we have given. What are we given? From the theorem, we write out this key point given. The first one we have a circle with center O. That's the first thing. Then the second thing given, we have a chord given. A chord. We can use any letter of our choice. If you like, we can say a chord AB. Now let's demonstrate that with a diagram as we are stating it now. We are given the first one we have a circle. So we can have this as a circle with center O. We have this as circle center O. Then we have a chord. We label that chord as AB. So we can draw a chord just touching the side, two sides of circumference. So we have chord AB. Okay. So, and also, what are we given? We have the mentioned angle at the center. Angle subtend at center. We can call it angle AOB at the center of the circle. So now, as we're written it, we connect it here. We have this connected together with this. So we have this angle now. Remember it's angle. So let's consider the one inside now, which is the obtuse angle. Also, we're talking about another angle at the circumference. So we can say the first thing we have angle, we can call it ACB at the circumference. At the circumference of the circle. Okay. So just pick any point at the circumference. We want to use the upper side now. Actually, the two sides is possible because we discovered that a cos of 10 to angle at circumference, one at the upper part and one at the lower part. Now let's consider the one at the upper part now. That is here. We form this angle at the circumference here, and we call this C. So we have angle ACB at the circumference. Okay. These are what is given. Now, what is required? What are we required? He said, to prove that the angle at the center is twice the angle of circumference. Now, that's the required to prove that angle at center, we don't need to write in word now, we write mathematically. Angle to prove that angle at center, which is angle AOB, is equals to 2 times angle ACB. That's what we are required. Then next step here will be construction. So there is need for us to make a construction here, and the construction is simply join point C to point O and extend to any point, say D. So join C to O and extend to, like, say point D now. So you can write it here. Join C to O and extend to point D. Okay, extend to D. Now we now enter the proof properly. So here I want to consider some triangles here. We have, when we look at this diagram now, we have this triangle AOC. Okay, from triangle AOC, now proof now, we consider triangle AOC. When we look at this, we see that two sides are equal. Side AO and side CO are equal. So let's say line AO is equals to line CO. You must have the reason why they are equal. Okay, why are they equal? Because they both come from the center of the circle. So both lines are reader. That is AO and CO. They are both reader. So that's what makes them equal. So therefore, we can say that triangle AOC is an isosceles triangle. It's not a property of an isosceles triangle that you have two sides equal. Also have two sides equal in a particular triangle. That triangle is an isosceles triangle. And also, in any isosceles triangle, the third side is the base. And of course, the base angle are equal, which implies that this angle and this angle is the base angle, which are also equal. So we can call this, since they are equal, we call this letter X. When we call this letter X, this will also be letter X. So we can then say that angle, the angle I mark now, you can label it the way we want. That's angle CAO is equals to angle ACO and is equals to X. Why? That's base angle of isosceles triangle AOC now. That is that. Also, as we look at this particular triangle, you discover that one of the side here is extended. This side is extended, and the exterior angle of any triangle is equal to the sum of the two opposite interior angle. That is, this angle marked now, this angle marked here, which is angle AOD, will now be x plus x, which is 2x. So we can say that angle AOD is equals to 2x. Why? Exterior angle of triangle AOC. That's the reason. So whenever one thing that we should note, whenever we are working on circle geometry or any geometry, there is need for us to back up our result or our answers with reasons. So why are we saying this and these are equal? Because of this. So it's very, very important. Now let's look at the other side as well. Okay, you have done with this side. When you look at this triangle BOC as well, it's similar to what we have done now. So we just quickly do that now. We discover that similarly, we can write similarly. You say triangle BOC. Is this BOC is an isosceles triangle. You know the reason why? Because line Y, line BO is equals to line CO. Why? Because they are radii of same circle. So that makes this triangle to be an isosceles triangle. And also the base angle here, this angle and this angle will be equal. So it's a property of isosceles triangle. That is why, you know, sequentially, there's some topic that will come before some topic. Like for instance, you want to be good in circle geometry, you should have good understanding of what is called plane geometry. And plane geometry, that's where we have all these isosceles triangle properties of, you know, plane figures, polygons, stuff like that. So, and we can use a letter since both this angle are equal. We can see this letter Y, this letter Y. Okay. All right. And same way, this is extended. This side is extended. This side is common to the two triangles. And this angle here, which is exterior angle, you have the sum of the two opposite interior angle. So this is 2y. Okay? Now, conclusion now. Because of space here, so I'm supposed to have written what I've done here. Now, the same way I've written this, no? Okay? So we can say conclusion now. Conclusion. From what we have now, we can deduce something there. That we have the whole angle at the center that we are considering, angle AOB, is now 2x plus 2y. So we can say angle AOB is equals to 2x plus 2y. Then what's happened? 2 is common here, right? And we can bring 2 out and say this is 2 into bracket x plus y. But also, when you look at the angle of circumference here, which we call but angle ACB at the circumference is same thing as x plus y. So we can say x plus y. So this is a fact on what we have in the diagram. And therefore, we can say angle AOB now will now be equals to 2 multiplied by, instead of writing x plus y now, we now write angle ACB. Therefore, the required has been proved. So that is that for the first theorem. So the basic understanding of this theorem will help us to tackle questions that are related to this in mathematics. And thank you for connecting. You are watching us live at Master T Math Class. This channel is dedicated for mathematics. Of course, we upload videos daily here, so you can be part of us to enjoy what we are doing. Just click on the subscription button and also share this video and be part of our community. Thank you now. Let's look at one application of this theorem. One application of it in a question that use this theorem that we just proved now. So for this particular question, we have this circle, given a circle like this with center O, and we have something like this. Instead of a chord, what they use an arc. So we label this as AB. And they put another angle as circumference here. And this angle is called C here. Okay. Then also we have we have an angle put there here, that's 26 degree, and they put an angle here that's 130 degrees. And the question says, although in this question here, there's a line drawn here, like a sketch, then it is coming out from here. Then you do another one here, something like this, just these two lines. Okay? And the question now says, the first angle they want us to find here, what is the value of angle CBO? CBO. So it is going to find one angle CBO. Okay? Now, when someone sees these three letters, the emphasis there is at the letter in the middle, which is at B. That is, we are moving from C to B, then through O. That means it connects from C, passing through B, then what B is where we are going. That is the angle between line CB and line BO. So B is common to them. So because some students find this difficult, whenever they give the angle to find, some will be saying, okay, find angle CBO. Where is angle CBO? If you don't know where angle CBO is, definitely you can't know what you are finding. So that's the first thing. Know where you are going. First question says, I should find this angle. Okay? Now, the second question says, find angle BOC. BOC. So between line BO and line OC. BOOC. So this angle. So these are the two angles you are finding now. Me seeing this question here, it resembles the diagram we draw for the first theorem. So it depends on what you can see first and do. That's why math is not just in one way. The way you do your own will be different from the way your friend does his or her own, and you still arrive at the same answer. Just back your result with reason that is compatible. Okay? Now what are we talking about here? This 130 degree here is angle at center. And this angle here, everything here is the corresponding angle at the circumference. And the theorem says that angle at the center is twice the angle at circumference. In other words, angle at center is bigger, 2 times angle at circumference. So in order for me to get angle at circumference here, which is angle ACB, I can say angle ACB now equals to angle at the center divided by 2. That's 130 degree over 2. And this will be the same reason as angle at center is equals to 2 times angle at circumference. It is allowed to abbreviate whenever we are writing reason like this. And this implies that angle ACB is equals to 65 degrees. All right. So now we need to know what we are doing. And here, angle ACB here, everything here is what we're talking about is 65. Now, I don't want to write that here. Now, let's look at this. This is 26. This is 26. Why? This angle is 26. This angle is 26. Why? Because this triangle is an isosceles triangle and these are base angles. So I can say angle ACO. Angle ACO would be also 26 degree. That's base angle of isosceles triangle AOC. You have already done something nice. When the examiner sees something like this, you'll be able to see that this is an isosceles triangle and the base angle are therefore equal. And I can get this angle like this. Why? Because everything here, we got it to be 65. So to just get this angle here, I'll just take 26 equals 65. That means I can say that angle BCO, angle BCO is equals to 65 degree minus 26 degree. You don't need any reason for this because it's already there. So this will now be 39 degrees. So this angle here is 39 degrees now. So these two should sum up to 65 degrees. That's what we have done. And to where we are finding now, this 39 degree, their angle at the base of an isosceles triangle. So this also will be 39 degree. So I can just say that the first question now, which is angle CBO, is now equals to 39 degree. Why? Base angle of isosceles triangle BOC. So that is that for that one. First one settled. Then in the same way, we have triangle BOC, and sum of angle a triangle. You have a triangle. The sum of angle a triangle is what? 180 degrees. So these three angles here, 1, 2, 3, must be 180 degrees. That means for me to get this one, there's a fundamental thing in geometry. So for me to get this one, add these two together, take it away from 180. We can now say that number 2, angle BOC is now equals to 180 degrees minus 39 plus 39. That's 78 degrees. That gives us 102 degrees. So that is that about that. We have several questions that we can apply these theorems on. So I believe you get something out of this class. But we are going to stop here for today. And when next we meet, we continue from here. Do well to subscribe and stay tuned, and also share this video, and you can be part of this community. Join any membership package of your choice. You can check our page for that. And thank you. See you in next class. Bye for now.